Hello all and welcome to today's New Economy Fireside chat series with me, Ashish Mehra. I'm the Chief Research Officer of Markets and Markets. At M&M, we take great pride in transforming market intelligence into revenue impact for our clients. We usually focus our research on disruptive emerging technologies and futuristic trends, which would lead to significant shifts in your revenues in the coming decade. And through these new economy fireside chats, our objective is really to share some actionable insights on new revenue growth opportunities, which may be emanating from disruptions in your ecosystem. And usually these are based on the client work that we've done or our own research. Now, I'd like to continue with the theme of sustainability, which we've been having for the last many talks. And for that, our topic for today would be CCUS, carbon capture. And for that, I'm very pleased to welcome my guest, Sarang, who is a leader in our energy practice. Sarang, would you want to say a quick hello?
Hello, Ashish, and hello to the audience as well. So today we are discussing the CCUS and the technologies that come under the umbrella of CCUS. And today, particularly, we'll be discussing the importance of direct air capture as a technology, which is among the negative emissions technologies.
Wonderful, wonderful, Sarang. That's great. So, Sarang, before we get into the direct air capture piece, I'd like you to set some context for our audience. Tell us a bit more about the importance of CCUS in helping attain carbon neutrality.
Sure, Ashish. So basically, the negative emission technologies, the adoption of those is right in the agenda, for all of the industry users, suppliers, everyone, because of the carbon net neutrality goal that they have. Crucial role as part of the economic, the sustainable route to the emissions, cuts needed to limit the global warming to 2 degrees Celsius. So in 2014, IPCC panel concluded that without the use of CCUS, the cost of climate change mitigation would increase by 138%. And further, that realizing 2 degrees Celsius scenario may not be even possible without CCUS technologies. Today, about 14 million tons of CO2 is being processed by CCS each year worldwide. And however, the global emissions are approximately 1,000 times more. As for the CO2 capture, one size fit all technology would not help to achieve the overall objective. So that's why no one negative emission technology or NET can feasibly reach a scale necessary within this century. Therefore, the deployment of variety of NETs is needed. However, the level of maturity among different NET technologies for capturing systems, CO2 varies across industries. Now, one of them is DAC, which is directly capturing the CO2 from the ambient air to generate concentrated stream of CO2. The captured CO2, then can either be stored deep in geological formations, or can be used in chemicals, building materials, or it can be used in food processing or combined with hydrogen to produce synthetic fuels as well.
So, Sarang, help me understand why is DAC emerging as is a very interesting option from a CCUS technology standpoint, and compare this to the other CCUS technologies for me, please.
Sure. So, as per the studies by IPCC as well as IEA, it's found that even with the efforts of electrification, energy efficiency, decarbonized power generation, and carbon removal by other means, DAC has a potential or a target in a way to achieve a carbon capture of 0.6 to 1.8 billion tons of CO2 that is to be needed just in the US to reach the net zero emissions by 2045. And DAC and one other technology called bioenergy with CCS were recently supported by the corporate net zero pledges from broad set of industries, including technology and online retail as well. So there is a growing awareness and interest from different corners of the industry or the corporate and the government and corporate stakeholders. The voluntary market for DAC-based CO2 removal has expanded with companies such as Microsoft, Stripe, Shopify, and Swiss Re purchasing future DAC removal to offset their CO2 emissions. So this is a connect which goes across the industry, which goes across multiple stakeholders, and that is why we are discussing DAC today.
And in more quantitative terms, where do you see, what's the likely percentage DAC in the overall CCUS market today, and how do you see this change over the next, let's say, decade?
Sure. So today, DAC captures about 0.04% of the total CO2 captured using CCS. The figure that we discussed earlier was 40 million tons. And if the plans go well, as per the tier 1 manufacturers or the DAC operators, they are targeting about 2 million tons of removal by 2025. So that would mean that there would be this penetration increase up to 3% by 2030, and then again up to 700 million tons by 2050. So that is the target that the DAC industry is targeting now. The application areas would be predominantly permanent storage, synthetic fuel, food and beverage. So these will be some of the leading end-use segments, which prompts this growth and demand when the capacity grows and the CO2 that is captured is more affordable to them.
And tell us a bit more about what needs to happen to enable this exponential growth of direct air capture versus other technologies, and what do you see as some of the restraints as well?
Sure. So the things that need to happen, first of all, is the increased and quick investment in large numbers, pretty much early on, so that the plants that are there in the development phase, they become successful, so that the large scale CO2 plants or facilities come up, and then they can be multiplied further in the coming years. Apart from that, policy support needs to come from the governments, that wherever the CO2 stakeholders are present. The industry buy-ins need to come from the consumers, so as to use or consume the CO2 that is being captured via the AC. And then some more interest needs to come from carbon offset buyers. And most importantly, I think the cost optimization efforts to be more successful, so that we have affordable industrial usage of CO2. So anything which is $100 per ton today will be more saleable in the market. At the moment, this number stands at, or this price stands, above $250 to $600 per ton, which is not feasible to be used in the industry. Another thing which needs to happen is the scale up of large facilities by leading DAC operators like Carbon Engineering, Climeworks, and Global Thermostat. They do have announced plans for the next 5 to 10 years, and that's an encouraging sign. For example, Carbon Engineering plans to construct a large-scale facility that will capture 1 million tons of CO2 by 2024, which again can be replicated further on to increase more capacity. Then Climeworks has also set a highly aggressive goal of 25 million tons per annum of CO2 captured by 2025. Apart from that, Global Thermostat has partnered with ExxonMobil to expand their capacity to be able to capture 1 million tons in coming years. So these kind of facilities need to come sooner, and multiples of these capacities need to come from the large players. At the same time, new players also need to come in, so as to have a wider presence geographically, as well as industry intervention that is needed to grow to a size that is effective to make a point in DAC capturing a significant amount of CO2.
Got it. Good. I think that's a good perspective. Now let's shift gears a little bit and talk a bit about revenue growth opportunities for various people in the ecosystem. And let's talk about equipment suppliers and also chemical or energy companies, right? Now, from an equipment supplier standpoint, some of the where to play questions would be around which countries to prioritize, which
Mhm.
end use industries and applications to focus on, etc. So, what guidance would you have for equipment suppliers to tap into this market of direct air capture?
Sure. So I would first take on the point of geography, attractive geographies, for example. So currently, the plants that we have, about 19 in operation, are majorly centered in US, Canada, and some parts of Europe, which needs to grow to newer geographies. And we see that GCC could be a big market opportunity coming in the near future. The reason being that GCC has abundant carbon storage capacity and it can play a strategic role in the necessary global scale up of CCS. This statement comes from Mr. Adam Sininsky, who is the president of Saudi Arabia's King Abdullah Petroleum Studies and Research Center, which is developing a circular carbon economy model, which helps contextualize the kingdom's climate policy plans, which is based on 4 R's: reduce, reuse, recycle, and remove, which also includes the remove part, includes the use of CCS and technologies such as DAC, and improve land management that safely can remove and isolate and store CO2. So the geography part is something to look out for in terms of new geographies coming in. As far as the equipment suppliers opportunities are concerned, DAC requires equipment such as air contactors, separation units, absorbers, vacuum pumps, pellet reactors, calciners, and blowers to run the facility. Now, the capital investment associated with a typical DAC plant ranges in the range of $665 millions to $1.8 billion, depending on the technology. So the overall equipment cost is about 15% of this investment. And overall, today, DAC technology is in its demonstration to commercialization phase, which means the equipment and enabling technology suppliers can have a great chance to participate and show their worth of products in terms of efficiency and ability to cut cost, rather, and gain foothold in the industry. We see that a period starting from 2025 to 2029 is going to be crucial when DAC's techno-commercial assessment comes clear, and a further path of more involvement, more scalability in facilities comes in, and the uptake for large-scale facilities will come right after that. So that means a big opportunity. So equipment makers need to convince the DAC operators that their product's performance aligns with the goal of high efficiency, circularity, lowest operating cost, and durability, as these equipment are supposed to run up to 25 to 30 years in extreme operating conditions.
Got it. And any thoughts on the most critical applications?
Yes, so as of now, we see that the solid solvent technology is picking up, which is an alternative to the liquid solvent technology. Both the technologies are at the moment high temperature technologies, but efforts are still going on to optimize the cost and reduce energy consumption. We may see a breakthrough in a year or so as to clearly identify which one is the most adopted or most favored technology in terms of economic as well as technological feasibility. As I said, the capex required per ton of CO2 would come around $850, meaning a market opportunity worth $170 million by 2025 is up for take, when the total CO2 capture by TAC reaches to 2 million tons per annum, and then a billion plus opportunity comes in when the target or the capacity reaches 15 million tons by 2030. OPEX is also one area constituting 4% of the capex.
And Sarang, if I were to take the lens of a chemical or an energy company, why should they prefer a more expensive option like direct air capture today? And conversely, how would the equipment suppliers convince these customers to embrace this particular option?
So basically, here's where DAC is different from other technology. DAC requires lesser land, and it can be placed, or the plants can operate nearby the storage or the end use facilities, which is an advantage. It doesn't have to be at the facilities of the manufacturer, whether it is a chemical manufacturer, for example. So it has the benefits of a modular construction, which can be expanded very easily when required. It also requires less infrastructure and land, as I said earlier. So these are some of the advantages. Besides, there are some disadvantages as well. So high energy intensive process and the high cost of CO2 to be captured at the moment. But as I said, we are in a development phase or pilot phase. In most of the cases that the efforts are being made, which we see to reach to a level where the cost could be optimized to $100 per ton of CO2.
Got it. Got it. Great. I think these perspectives are very, very useful, Sarang, and thank you so much for sharing this for our audience today. And folks, thank you so much for participating in today's talk and listening in. Until next week, wishing you all the best and goodbye for now. Thank you. Thank you, Sarang, once again.
Thank you, Ashish. Thanks a lot, everyone.